So in this video, we'll be discussing what a process and what are threads and what are the differences between them. So what are processes? Processes are basically programs that are being dispatched in the CPU, that are being run in the CPU. They're being dispatched from the ready state and they're scheduled in the CPUs for execution. So, a process control block holds all information about a process. It holds all the metadata about a process. So, it holds the concept of a process control block, or a PCB. A process can create many other processes as well, and those processes are known as the child processes. In your Unix system, using the fork system call, you can create multiple child processes. Uh, generally, a process takes more time to terminate and it is isolated, meaning that uh, it runs autonomously on its own, generally, and it does not share any memory with other processes. So, even a child process will not share its memory with its parent process. So a process generally has six states. New state, the moment process is come, then it is in the new state. The other state is a ready state. So process is moved into a ready state just before it is scheduled for execution in the CPU. The other state is the running state. Running state is when a process is running in the CPU, when it is being executed in the CPU. Uh, the next state is the waiting state. So in the waiting state, let's say a running process has been blocked or it is put on hold, then it is pushed into the waiting state. The last two states are terminated. Terminated is once the program is completed its execution, it will be put into the terminated phase. Uh, and the last one is suspended. Suspended is when a sudden error occurs in the execution of a program, then it is put into the suspended state uh, for the error to be resolved. So let's look at what threads are now. So a thread is a segment of a process. So which means that a process can have multiple threads and these multiple threads are contained in a process. So a, a thread is basically a lightweight process, meaning that it uh, shares its memory unlike that of processes. There are three states for a thread which are running, ready, and blocked. Thread takes less time to terminate as compared to a process because it's lightweight uh, and unlike the process, threads are not isolated. They do not completely work autonomously, meaning that they share some memory. We'll see in detail what those differences are between a process and a thread. First difference is that process means any program in execution. So any program in execution that's running in CPU is termed as a process. Threads are segments of process. Threads are parts of processes that run uh, individually. So a process takes more time to terminate. Thread takes lesser time to terminate. That's straightforward, basic. Uh, Process takes more time for creation because it's heavyweight, and threads take less time for creation because they're lightweight. Processes take more time for context switching because they do not share the same memory. Uh, Threads take lesser time for context switching because there's already some shared memory. Process is less efficient in terms of communication. Threads are more efficient in terms of communication. Processes are isolated. Threads share memory. A process is a heavyweight process. Processes are heavyweight. Threads are lightweight. Process uses interface in an operating system. Thread switching does not require calling an operating system, causing an interrupt to the kernel. If one process is blocked, then it will not affect the execution of other processes. If a user level thread is blocked, then all other user level threads are blocked. Process has its own process control block, stack, and address space. Thread has parents PCB, thread control block, and stack and common address